Example 3 is the same as example 1 and example 2, but now we have an x cubed graph. But the steps are the same. When you're doing a square root of any function, you first find out all the points that are 0 and 1, because those are going to stay the same. So I'm going to mark, here it's 0, here it's 0, up here it's 1. Then, all the values between 0 and 1, your graph is going to be above the original graph. So this section is probably going to be the easiest to see, I can make it above that way. Are you okay with that? This section is going to be a little bit harder, but you just need to make it go above. Danger, though, why is this bad? That's above, but it's too much above. Even this would be bad. What's the limit that we could go up to?
Oh, I'm sorry. This is not. There's a question.
The maximum it could go up to is 1, because here is where 1 it's the same, right? But this one never would go past 1. So that would be acceptable. Anything between 0 and 1 would be fine. But it still needs to show that it's above. And then after y equals 1, your graph is below. So this would be fine for your final graph. State the domain and range. X is bigger than or equal to -1. Interval notation, that's 1 to infinity. Range, y is bigger than or equal to 0. 0 to infinity. So example 1, 2, and 3 are all the same concept. Doing those steps of finding out where it's 0 and 1, graphing it slightly above, graphing it below. Questions 10 and 12 for practice. And of course, where the original graph is negative, your graph doesn't exist because you can't take the square root of a negative.